Hello, I'm Andy Briggs, and welcome to the amazing Astronomical Alphabet, a weekly programme in which my Astro Radio co-presenter Daz and I will be talking about anything astronomy related which begins with the week's letter of the alphabet. We'll each choose some things to talk about which are in some way related to the universe, but neither of us will know what the other has chosen. We will then reveal facts about them which are weird, strange, bizarre, or simply interesting. Well, welcome back, dear listeners, to the amazing Astronomical Alphabet with me, Andy, and him over there, Daz. How are you, Daz?
Oh, thank you. Fine. Thank you very much, Andy. We got some nice weather, and I'm hoping it's going to continue till tonight. And maybe I might be able to see Jupiter and get some photographs.
Oh, that'd be great. That'd be great. Yeah, we're clear at the moment, but of course, on the going by the last couple of weeks, it's going to cloud over later, like it did last night, and we actually had some rain, which is the first rain we've had in about nearly a month, I guess. So let's wait and see what it does later. I think we're beginning to see the first signs of our summer cooling down. We're down to about 29 degrees today, 29:30.
Okay.
So I think it's showing the first signs of coming to its inevitable end. And to be honest with you, much as I love the weather here, because our summer lasts for about 6 months, it does get a bit much after a while, especially when you have to keep switching on fans and air conditioning everywhere you go, which of course doesn't do the old electricity bill any good. But I don't complain, because this is a wonderfully beautiful place to live here in Catalonia. So no complaints from me. So today we are scaling the rather obvious right angle of the letter L. And we're going to plummet down into the depths of astronomy and see what wondrous things we can find to amaze and entertain you, beginning with the letter L. Now, I believe, Daz, it's your turn to go first this week.
I believe as well.
So crack on then. Let's have your first one.
Well, I hope you enjoy this one. This is one that I found, it was brought to my attention today. And I must thank Tracy Snellis from the North Wales Astronomical Society. She posted this.
Oh, yes.
And it's something that I think very few people will actually know about.
Try me.
And L is for London, as in the Great Fire of London.
Well, I've heard of that.
Now I can see that you're all very
yes. 1666, Pudding Lane.
The
monument, all of that stuff.
Yes, well, you're on the right track with the monument.
Ah,
right. So, did you know that at the base of the monument, underground, there is a secret laboratory?
Ah, it's not Dr. Evil. It's not Dr. Evil, is it?
Yeah, well, you never know.
So what the hell is a laboratory doing under the monument?
Right, okay,
just in case our listeners in far-off lands don't know, the monument in London, just around the corner from Pudding Lane, which is where the Great Fire of London is meant to have started, is a tall monument to commemorate the Great Fire of London, which devastated most of the then city of London in the year 1666 and led to the city being more or less completely rebuilt as a proper city and not out of wood as it had been basically before that. And it's got steps inside. You go all the way. I forget the height of the monument, but I remember it's a lot of steps up there. And from the top of the monument in London, you can see 9 continents, which I don't think many people realise. So
9 continents.
That took you long enough. Just seeing if you're awake, Daz.
Don't you mean counties?
No, I mean continents, mate.
Well, there is a big globe on there, so you probably
that's true. Very true.
The only
anyway, tell us about this subterranean secret laboratory.
Right. Okay, then. Well, do you know who actually built it?
Was it Jones and Son Builders?
No. It wasn't Trotter Independence.
Oh no,
it was. It's actually the plaque at the base of the monument itself said it was Sir Christopher Wren.
Well, I was going to say, did he have a hand in it? Because
yes, he did have a hand in it. But that is not strictly true.
Is it not?
No. All right, I'll just read this out for you because, like I said, I've only had a couple of chances to have a look at it. The monument is one of London's most famous landmarks, even given its name to a local tube stop. Monument Station. I can't remember that one.
Oh, I don't know that one well.
But this tribute to London's greatest fire also has a secret second use as a giant piece of scientific equipment. At the base of it, there is a ticket office because, as Andy said, it is hollow and there's some stairs that you can actually climb.
Yeah.
And in the ticket office, if you climb to the very top, you can get a certificate which basically declares that this is to certify that Joe Bloggs, or whatever the name is, has climbed the 311 steps of the monument to the top.
Just to certify you've survived.
Yeah. The thing is, this is, yes, you've climbed 311 steps, but there is actually 345. In the base of the ticket office, there is a hidden door. And when you open the door, I'll just read a bit more, just so that you know what's going on.
This is intriguing.
The monument to the Great Fire of London consists of a towering 202 foot, which is 61 meters, stone column, decorated with dragons and topped with a flaming golden orb.
Mm-hmm.
On the inside, a striking staircase spirals up to the very top, twisting up like the peel of an apple carved in a single continuous ribbon.
Yeah.
For years, a cracked plaque tacked at to the base explained that it was designed by Sir Christopher Wren. Again, this isn't entirely truthful. It makes a lot of sense that the capital's beloved monument would be born of Britain's most celebrated architect.
True.
After all, he was the main rebuilder of London after the Great Fire had basically burned everything to the ground within the city walls, which included 13,200 houses and numerous extraordinary public buildings, from riverside castles to Whittington's Long House. One of the, of course, we all know, Jack Whittington. Dick Whittington.
Jack Whittington.
Yeah, old Jack.
Jack.
Dick Whittington, yeah. In fact, the monument was designed by his close friend, a scientist, Robert Hooke.
Aha!
Now we're getting to the bottom of it. Wasn't Robert Hooke the nemesis of
Newton?
Newton, yeah.
Yes, absolutely.
They had a love-hate relationship, didn't they, sort of thing?
When Newton made his famous quote about he had managed to get where he had got to by standing on the shoulders of giants, that was a subtle dig at Hooke, who was very short. So yeah, that's right. So it was a great thing, but he was actually having a dig at Hooke and his lack of physical stature. So yes, they were enemies, and Hooke has gone down, as a very, very underestimated scientist, because the things Hooke did, especially in the realms of biology, were absolutely stunning. And he was eclipsed by Newton. Hooke, by all accounts, was not exactly a dwarf, but he was sort of Ronnie Corbett size, and apparently not a terribly attractive man. And Newton really didn't like him at all. They didn't get on at all.
No, so, I've seen some of the letters they sent to each other, and they are quite barbed in certain respects and all that. But yes, we digress.
We did. Sorry, getting back to the secret lab.
Yeah. Robert Hooke was a man of many passions who, as you were saying, he did a lot of things, who applied his inquiring mind to subjects as diverse as chemistry and map making, at the sober end of the scale. And folk beliefs that toads, and folk beliefs, so that folklore about toads and his own bowel movements at the other. Okay, that's nice. In his day, he had a reputation as lofty. Well, he was short, wasn't he? That's a bit that's lofty as the pillar as himself. Variously described as England's Leonardo, and certainly the greatest mechanic this day in the world. So that's in Old English. That's why it's just sort of.
He was, in fact, an amazing scientific illustrator. I seem to remember a set of drawings I saw of fleas that he had done, and they were stunning. I mean, the artistry in them was just absolutely unbelievable. So,
Yeah.
yeah.
Today, his name has largely been forgotten, but his contributions have endured. Among other things, he coined the word cell to describe the basic unit of life, so the cells in your body.
That's right.
They reminded him of monks' rooms or cells.
Mm.
He devised Hooke's law of elasticity.
Elasticity, yes.
Elastic, yeah,
Yeah,
elasticity.
elastic, all that, yeah.
Arguably not particularly exciting, but useful, and invented mechanisms still used in clocks and cameras to this day. After the fire, Hooke tried his hand at architecture too, designing hospitals, civic buildings, and churches across the city. He didn't get a lot of credit, partly because most of his achievements were signed off by and mistakenly attributed to Wren, and partly because some of them weren't very good. Oh dear.
Mm.
Of course, one of the one such project was Bethlehem Royal Hospital, which
Yes.
was the Bethlehem Royal Hospital, which was for patients with, as we call it now, with issues. But it
Right.
was basically mocked. It was widely mocked as the palace for lunatics.
Oh,
But
gosh.
of course, we know Bethlehem Royal Hospital because it gave us the corrupted word of Bedlam.
Yes, that's right.
Yeah.
That's right.
Then came the monument. It was supposed to be a grand acknowledgement of the fire, but at the time, what Hooke really wanted was to build a very long telescope. In the end, he decided to combine both. Today, the room, if when you, as I said, when you pull up this hatch
Trapdoor.
that's in the trapdoor that's in the bottom of the ticket office, you descend 35 stairs, if I remember rightly, and eventually you find yourself in a domed room with a room with a domed roof. The ancient brickwork walls are bare and crumbling, and it smells damp, like clothes that have been left in the washing for far too long. This part is usually off limits to the visitors, though I can't help thinking they would probably don't mind all that so much. Today, the room is empty except for a wireless router and some sensors, and they were put in when the building next door was built, so
Right.
as to measure disturbance just in case they knocked it down.
Right.
But a few hundred years ago, it was a state-of-the-art physics lab. When you go into the center of the room, looking up through a metal grate, there's a clear view all the way through the spiral staircase up to the highest point in the building, right at the top. Hidden inside a decorative golden orb is yet another trapdoor, this time made of heavy iron. When it's open, you can look all the way up from the basement lab into the night sky. In fact, the entire building is a giant telescope.
How amazing. I never knew that.
Yeah. This isn't as bonkers as it sounds. Back in the 17th century, scientists were still arguing about whether the sun revolved around the earth or
Yeah.
the other way around.
Mm.
Like all rational people today, Hooke was thoroughly convinced by the latter, but no one could prove it. In theory, it should have been easy thanks to astronomical parallax, an apparent shift in the position of one object against the backdrop of the other.
Yeah.
As we all know, if you hold up your thumb at arm's length, look at an object, and then look with one eye, then the other eye, and you can see that your thumb seems to move across the thing. And this will give you your parallax. By measuring the
That's
angles,
right.
you can measure distances. And to do this astronomically, they use the actual Earth, the orbit of the Earth, to do this. So scaling this up, if the Earth changes its position relative to the stars when circling the sun, then they should appear to jump from one place to the other
And they
over the
do.
course of the year, and they do. The catch is just how tiny these movements are. Like Gamma Draconis, the star, a giant orange-colored star, around 900 trillion miles, which is 1.4 quadrillion kilometers away. Instead of measuring the movement of the objects in the sky from planets to satellites in meters or inches, astronomers divide the heavens like the face of an imaginary clock. Every 6 months, the star moves north or south in the sky at a scale equivalent to the hands moving 22 10,000ths of a second.
Oh, really? Oh,
Yes, that is minuscule. To magnify parallax, though, to see, you need a very large telescope. Hooke's first idea.
Just 1 second.
You carry on.
About this telescope and the monument. Did it actually? So there was a lens on top of the orb at the top.
Patience.
Sorry, am I jumping ahead?
Young man. Your patience is a
and
virtue. And
talking of hands of clock, have you got our timer on?
Oh, no, we will soon sort that out. Okay. We've been talking anyway. What was I going to say? Scaling up the word to catch the movements. 10,000. To magnify parallax enough to see it, you need a very large telescope. Hooke's first idea was to embed one in his lodgings at Gresham College, where he was professor of geometry. The 36-foot, which is 11-meter telescope, was so large, holes had to be cut through the structure of the building. In the end, it passed through 2 floors and out through the roof. Next, Hooke chose his star, Gamma Draconis, was an ideal candidate because it's relatively bright and passes directly overhead. Now, all he had to do was wait for it to pass overhead. He was ready to change our perspective of the universe once and for all. Except it didn't work. The measurements depended on linings the lenses up exactly, but the structure was so unstable, they were fixed in place using a wooden structure, a material known to expand in the heat and flex in the wind.
Of course.
So, of course, that failed. So when he had the opportunity to design the monument, he thought, aha. This time he determined the structure would be sturdier. His plans called for 28,196 cubic feet, which is 798 cubic meters, of the finest Portland stone, which is roughly the weight of 14 blue whales.
Wow.
This basically was not going to be a flimsy tube. It was built not to flex. The construction took the best part of 6 years, but mostly took so long because they kept running out of stone. Eventually, the king issued a proclamation forbidding anyone from transporting rocks from the Isle of Portland without first consulting Wren, who was officially in charge of the project.
Right.
There were a few hiccups on the way. And one of them was that it was discussed that they would actually top the monument with a statue of King Charles II, which would have ruled out it being used as a telescope.
Sure.
So Christopher Wren, being cunning, said, Wren was like, "Oh, I know what you mean, but wouldn't it be better to have this nice golden orb on the top? Then you can use it to shoot fireworks."
What?
Yeah, to shoot fireworks at the top of. But of course, that wasn't in the forefront of people's minds.
No.
Luckily, the king refused to have a statue of himself put on the top anyway, because he thought it might make it look like he was responsible for the fire.
Ah, yes, yes.
Hooke had got his way.
PR concerns even in those days.
Yeah, of course.
Yeah.
Well, of course, King Charles II, he was too busy lobbing off the head of the Commonwealth people, wasn't he? So,
yes, that's right. That's right.
Hooke got his way and it was completed in 1677. Originally, lenses would have slotted in at either end of, and the observer standing in the lab would take measurements of the stars using a special eyepiece. This time, surely Hooke would have his way, but then disaster struck. He was trying to keep the two lenses aligned 200 foot apart, with only limited ways to anchor them to the telescope. Worse still, the monument was next to Fish Street Hill, which was the main route to London Bridge at the time. This was one of the busiest roads in London, mere meters away from his highly sensitive scientific equipment. In the end, vibrations from the traffic ruined everything, so it didn't work.
What a mistake to make up.
Yeah, parallax wasn't discovered until 1838 by a German astronomer, Friedrich Basel, but it isn't quite the end of the monument story. In the 17th century, high buildings were rare. The highest building at the time was Strasbourg Cathedral, which was twice as high. Previously, Hooke had been forced to conduct experiments requiring height from the top of London's Westminster Abbey or St. Paul's Church.
Yeah.
Now he had his very own laboratory for trials on the effects of height, particularly on pressure surrounding air. We won't go into that. Hooke was using a barometer to measure how pressure changed as he walked up the pillar. He had planned the monument very carefully. Each step was exactly 6 inches tall, so he could track the changes in pressure with precision between the bottom and the top of the stairs. The mercury level dropped by about 1/3 of an inch, confirming that air pressure decreases with altitude. Finally, a successful experiment at the monument. Who cares that this had been done 30 years earlier, even if it was quite simply walking up a mountain?
Oh, no. Yeah, did you see? Hooke just didn't have the right stuff, did he?
No, bless him.
He was, born to be a failure, I think. Or born to be seen a failure.
It's such a sad state.
I know.
Yes, he had so many achievements, but he had so many failures as well. But as I said, we'll get back to the original thing, is that nobody really understands or knows that is actually originally designed to be a massive telescope.
Well, I never knew that. And I wish my dad was still alive, because I remember him taking me to the monument and going up the steps with him and him explaining the history of it. But he didn't know about that.
No. So, if he'd gone down, he would have found a little room. And if you looked up through it, you could see it.
My dad would have been absolutely fascinated with that. That would have been exactly, I was going to say up his street, but probably below his street, obviously.
Yeah.
So, that's amazing.
I thought that was a fascinating one, yeah.
That is truly amazing. I shall never look at the London Monument in the same way again. And next time I'm in London, if I can ever get back to the UK with this pandemic and whatever, which is still generating more bureaucracy than you would believe. But next time I go to London, I will definitely go to the monument, and I'm going to ask them if I can have a look underneath their trapdoor. And
yes, but how long have you got left on your banishment from this country?
Well, exactly, not long. The leg irons come off next year, so any time after that, really. Yeah. At least I got my striped jersey off now. So and now I'll be over when circumstances allow. My sister's trying to get 2 weeks holiday in France at the moment from the UK, and the things she's running up against in terms of bureaucracy and the fact that the rules keep changing, and you've got to have this paper and this paper, and
this test, that test.
Yeah, exactly. We obviously need to be very, very careful. But anyway, next time I go to London, I shall definitely have a look at the monument again, because I used to work not far from there. I knew the St. Paul's area and down there to the monument quite very well, and and it was my father's stomping ground, because my father was a broker in the City of London for nearly 30 years. So he knew the whole of the City of London at the back of his hand.
Excellent.
So there we are. Thank you so much for that, Des. Very, very interesting.
Yeah.
This is Astro Radio, and you're listening to the amazing astronomical alphabet. L is for LIGO. Have you got LIGO on your list today?
I'll just tear mine up.
Oh, you've got it, have you? Oh well.
Yeah, you carry. I know this is your baby. You love this.
Well, it's not my baby exactly, but I've got a bit of a perspective on it.
Yeah.
LIGO. What is LIGO? LIGO is the Laser Interferometry Gravity Wave Observatory in the United States. There are two of them, in fact, one in Louisiana and one not. And one's up near in Washington State, that is. And this is the instrument that detected the first gravitational waves in 2015. And it was an historic discovery, because gravitational waves, these minute, absolutely minuscule ripples in space-time, about 1,000th the diameter of a proton of an atomic nucleus, these vibrations in space-time were predicted by Einstein, and then they were unpredicted by Einstein. and then they were predicted by Einstein, and then unpredicted again, because literally over 20 years, he couldn't make up his mind as to whether they actually existed or not. And in the end, he came to the conclusion that, yes, they do, but humans will never have the technology to detect them. And in 2015, the LIGO Observatory proved him wrong. And the reason there are two LIGOs is, of course, for confirming the gravitational wave signal, because if one observatory detects it and the other doesn't, you might be inclined to think that it was instrument noise or equipment malfunction. But if both of them detect the same signal, you're pretty sure it's real. And they are separated, the two observatories, by exactly 10 light seconds. And the first gravitational wave signal took 10 nanoseconds or whatever, 10 light seconds, I'm talking about 10 nanolight seconds. And it took that time to travel between the two observatories, thus confirming that gravitational waves travel at the speed of light, which was a prediction of Einstein. Now, these gravitational waves, as you might know, I won't dwell too much on the cause of them, but they are generated by extremely massive objects like black holes in the universe when they merge, when neutron stars collide, when neutron stars and black holes collide. They generate these ripples in the fabric of space-time that travel through everything. So even through you, because on the 15th of September 2015, you as a thing, as a body, were stretched and distorted by the 1,000th of the diameter of a proton. And it was an immense technical achievement to detect these, because it's opened up a whole new world of astronomy. Gravitational wave astronomy, very much in its infancy, is going to reveal a lot about massive objects in the universe. And not just black holes and neutron stars. Now, very soon, we'll have the technology to detect gravitational waves from, for example, colliding supermassive black holes, from supernovae explosions, and almost certainly things that we don't know about, because whenever in astronomy we've used a new way of looking at the universe, we've always discovered things that we had no idea were there. And there's no reason to think that gravitational wave astronomy will be any different. So it's a really exciting future for it. Now, LIGO as a project goes back not to 2015, not even to 10 years before that. LIGO as a project started in the 1980s to build the world's first gravitational wave detector. Well, no, I should say the world's first gravitational wave detectors that actually worked, because there had been several claims of the discovery of gravitational waves before that, but they didn't bear out. They were never confirmed. And in fact, looking at the equipment that was being used, the waves were far too small to be detected. And the way that LIGO works is to basically have two tunnels at right angles to each other, which are a couple of kilometers long, shooting a laser beam down to the end of the tunnel, where there's a very special mirror. It gets reflected back. And it's actually the same laser beam that's been split into two. And when it arrives back, the beam is recombined into one beam and is fired at a detector, which just detects the presence of light or not. Now, if a gravitational wave passes through the Earth, the distance between those mirrors changes as space-time is squeezed and distorted. And this causes interference in the laser beams, so that when they're recombined, they keep going out of phase. Another way of saying that is they flicker. So the detector sees a flickering of the light as the distance between the two mirrors changes. And this is how it works. Now, this is often called the world's most accurate ruler, because obviously it needs to know the distance between the mirrors to an exquisite accuracy. And in fact, if you look at the distance between Earth and Alpha Centauri, the one of the stars closest to us, just over 4 light years, LIGO could measure that distance changing by the thickness of a human hair. over 4 light years, which is an absolutely stunning accuracy. I first came into contact with LIGO in 1987 because a lot of the mathematical research behind it was being done at Cardiff University in Wales. They had a LIGO team there just doing the maths basically and doing the basic engineering research with the maths. And I met a gentleman there called Bernard Schutz, and just by chance, I met him in a shop one day, and we got, for some reason, as you do with people you just meet in shops, you get talking about gravitational waves. And he was telling me all about his work doing the maths research behind it and the basic engineering research at Cardiff. And I just became absolutely fascinated. And that's when I started following the subject and seeing what was going on with this project that he was telling me about that eventually became LIGO. So that's LIGO for you, an incredible scientific instrument. It's now not the only gravitational wave detector, because in Europe, near Pisa in Italy, well away from the tower, luckily, we have the Virgo gravitational wave detector, which joins LIGO, the 2 LIGOs in the US, in its observing runs. So now we have 3 gravitational wave detectors. So if you have 3 gravitational wave detectors detecting the same signal, you know you've got something. But the other thing that having 3 allows you to do is to triangulate the source of those gravitational waves on the sky. With just the 2 LIGOs, where the waves that come from in the sky was very difficult to pin down. You end up with a big area of 30 degrees or more on the sky, and the source could be anywhere in there. But with Virgo, you can narrow it down much more. There are plans for more detectors. The Chinese have announced they're building 3, and they want to become the world leaders in gravitational wave astronomy. India has just broken the ground on their first gravitational wave detector, although that has now been put back, I understand, because of COVID, and there won't be much movement putting that forward in the near future. But Europe also has plans, and other plans. There's actually another gravitational wave detector in Germany, but it's on a much smaller scale, and it's used as a sort of a test bed for the technology rather than a working gravitational wave detector. So there you are, the wonderful, wacky world of gravitational wave astronomy, which is opening the universe to us in unbelievable ways. If you think about this, for the whole of human history, the only way we've known about the universe is through electromagnetic radiation, light, X-rays, radio waves, gamma rays, etc. Gravitational waves are not on the electromagnetic spectrum. They're a completely new and different window on the universe, because it's not about radiation traveling through space. It's about space itself rippling as the result of the immense release of energy of these massive colliding objects. And the future is incredible for gravitational wave astronomy. At the moment, both LIGO and Virgo are offline for upgrades, which will greatly increase their sensitivity, it is thought, it is hoped. They'll be back online sometime in the spring next year, so watch out for that. Up until now, they've discovered about 50 black hole mergers, at least 2 neutron star collisions, and at least 1 black hole neutron star collision, and a couple of other events that they really haven't identified yet or got much information about that could be due to equipment noise, but we'll have to wait and see. Anyway, Des, I just thought I'd give you, sorry if I went on a bit there, but I just thought I'd give you a few things about LIGO to ponder.
Yes, because as you said, we've got the 2 LIGOs and the Virgo. We've also got CAGRA. Is that?
Oh God, I forgot about CAGRA. CAGRA is yes, sorry. CAGRA's the online gravitational wave detector. Came online just under a year ago. I think it was
2019. It says there. So.
Oh God, how time flies. Well, okay,
yeah,
2 years ago then. This is very different, because this gravitational wave detector is underground in an old mine to isolate it from vibrations, and works in, it's still an interferometer, works in the same way because you can't really do it any other way. but it's underground, because one of the problems at LIGO is that it's very difficult to rule out or eliminate vibrations that are on the Earth from your signal because of its incredible sensitivity. The Hanford LIGO, for example, is about, if I remember rightly, more than 200 miles from the sea, but they still have to adjust for the sound of waves crashing on the beach from 200 miles away. And that's enough to upset it.
Yeah, because isn't one of the LIGOs quite a few miles away from a railway line? And they
Yes,
have
that's
to have
right.
They've got to have the timetable to
Exactly, exactly.
when
But the good thing about earthly vibrations is you know what they look like. They have a predictable signal, so you can eliminate them from the data. You can take them out of the data. However, they are a nuisance. But the Japanese thought, well, let's put one deep underground, well away from any earthly vibrations on the surface. They had to build a very sophisticated system to isolate Kagra from seismic activity, of which there's a fair amount in Japan, as you know. But again, seismic activity has a predictable signal, so you can filter it out of your data. But yeah, it's all interesting. So we've got Kagra as well. So and as I said, there will be several more online in the next few years, and every extra one. Every extra detector that comes online allows you to have basically higher resolution on the signal. And in the same way that, VLBI with radio waves, the more radio telescopes you have, the higher the resolution. So it's the same sort of idea. So, so there are doubtless many huge discoveries to be made with gravitational waves yet. And I, for one, can't wait for LIGO and Virgo to come back online. The Japanese haven't really announced anything much from Kagra. I haven't seen any amazing discoveries from Kagra. So I'll have to check out what's going on at Kagra.
I think there was something the other week about between Virgo and Kagra. There was something, but I don't think it was because they haven't got the sensitivity of because they're not as big as the LIGO.
No, they're not as big as LIGO. No,
but also as you said, we've got more coming online. You've got in the 2030s. You've got the Einstein telescope, which is going to be underground. That's going to be a lot larger.
Yes.
Than what we've got at the moment. There's one called the Cosmic Explorer.
That's right.
You've got the Chinese one, Tianqin and Toyaji.
Yeah.
And then of course we've got the space ones.
Yes. Lisa,
which I really love to see that get up in.
Me too. But that's not due to launch till 2034.
Yeah, so. I mean that's going to have arms that are millions of miles long. So
2.5 million kilometers.
Yeah, so it's absolutely fantastic.
So there you are.
Because the detectors are also linked to visual telescopes as well.
Yes.
And within 15 minutes of a possible detection, they notify all the telescopes that are in the system, and then all those that are available will swing round and see if they can see anything. And this is before it's even been confirmed as a true gravitational wave, because time is of the essence. And of course, the more detectors we have, then the quicker we'll be able to get on them. And they have detected, they have actually watched some of these events happen because of the speed. It was thing. Yeah, it's fantastic. I mean, I like you said, I love the gravitational wave detectors and what they're bringing to us. I've got an app on my phone called Chirp.
Yeah, I've got the Chirp app as well. It's been sadly quiet recently.
Yeah, well, of course since they've taken down the LIGOs that they haven't really been using them. So I think it's 2020 March. I think was the last peak. But it pings off, and I'm looking there. And when you go into it, there's a lot of technical data, but you can also glean which telescopes of these visual telescopes or radio telescopes have swung round to it and which have reacted, and it's really good.
Yes, if any of our listeners want to keep up to date with and be alerted about the latest gravitational wave discovery, the Chirp app, which I think you can probably get by searching for Chirp Birmingham University, which is where it comes out of. Really useful little app for keeping up to date with the latest gravitational wave sources. And Daz will tell you, I mean, it's quite exciting when you get a new event and they have the basic information about it, and you're trying to work out what the hell was that? Was that a black hole merger or a neutron star merger? Getting back to what you said about the multi-messenger aspect of it, multi-messenger astronomy is basically where you're looking at an event in lots of different wavelengths, plus now gravitational waves. The one I remember is GW 170817, which was the first positive detection of two colliding neutron stars, and it was detected first through gravitational waves, and then it was detected in gamma. Then it was detected in all sorts of other wavelengths, leading up. Hang on, I'll tell you exactly the sequence of events here. Just give me 1 second, because I've got it here somewhere. So I've got a timeline here. If I can just find it, just bear with me 1 moment. And it was an absolutely amazingly different signal to a black hole collision, because two neutron stars collision gives you a very, very different signature. The first thing to say about that signal was that whereas the collision of two black holes lasts maybe 1/10 of a second, this event in 2017, the gravitational wave signal lasted nearly a minute. And it was detected, first of all, as I said, in gravitational waves. 1.7 seconds later, the Fermi Orbiting Gamma Ray Observatory detected a blast of gamma rays from the same area in the sky. 11 hours later, astronomers found the explosion in a galaxy called NGC 4996. 15 hours later, there was a blast of ultraviolet light detected by the Swift Orbiting Observatory. 9 days later, it was detected in X-rays by the Chandra Orbiting Observatory. And 16 days after the gravitational wave event, it was finally found in radio waves by the VLA in America. So it was an amazing event. But the important thing was this was the first time that we'd seen an event in gravitational waves first, and then the radiation, the electromagnetic radiation from that humongous explosion, which was at its peak 100 million times brighter than the sun, would you believe, generated all this radiation that was picked up at various times after the event. And there are reasons why all these signals arrived at different times, which has told us a lot about how the explosion evolved when these two neutron stars collided. So there you are.
Okay, my next one, it's a bit of a short one, but it's a bit of a history lesson as well.
Right.
It's have you heard of a chap called Knut Lundmark?
This is not King Canute who told the waves.
No. Tried to hold the waves back, but he got wet feet.
No.
Yeah.
No, I haven't heard of him.
That's another story, Mr.
Enlighten us.
Yeah. Knut M.L. Lundmark in June 1889 was, I'll take it he was born then, in Älvsbyn, Sweden, 23rd of April and whatever, was a Swedish astronomer and a professor of astronomy and head of the observatory at Lund Observatory in 1929 and 1955. Now, he was a contemporary of Mr. Hubble, and he actually worked at the same time at the same observatory that Hubble made his discoveries about galaxies and the fact that the galaxies are moving away from us.
Okay.
And he was there about the same time as well. Lundmark received his astronomical education at the observatory at Uppsala University. His dissertation was titled "The Relations of the Globular Clusters and Spiral Nebulae,"
right?
At the relations of the nebulae to the stellar system. During the 1920s, he worked at several observatories in the USA, mainly the Lick Observatory and Mount Wilson. So that
right.
And as I said, he was there at the same time.
Same time as Hubble. Yeah,
Hubble was there. Yeah. Knut Lundmark was one of the pioneers in the modern study of the galaxies and their distances. He was one of the first to suspect that the galaxies are remote stellar systems at vast distances and not nearby objects belonging to our own galaxy, the Milky Way. In 1919, he measured the distance to M31, the Andromeda galaxy, to 650,000 light years.
Oh, bit
about
out.
a fourth of the, just a tad,
Yeah.
about a fourth of the present day value, using magnitudes of nova found in M31 and comparing them to nearby ones with known distances. Lundmark's work contributed to the later famous 1920 Great Debate.
Which you were talking about a little while ago.
Exactly, yes.
Right.
Over whether nebulae were galaxies or concentrations of glowing gas. Lundmark also studied the light distribution in the galaxies and discovered that the distribution could only properly be explained if the galaxies contain vast amounts of light-blocking dark clouds.
Wow.
He was the leading writer of popular astronomy among the professional astronomers in Sweden in the 1930s and onwards. He often appeared in on the Swedish National Radio with programs on popular astronomy and history and science. He made basically a generation of Swedes fascinated in astronomy.
How sad therefore that he's been sort of forgotten. It's
yes,
sad, isn't it?
Yes, and in studying this, I mean, he has got a moon, a crater on the moon named after him.
Right.
He also has a galaxy or a joint name, the Wolf-Lundmark-Melot galaxy.
Right.
Which is named after Lundmark, Max Wolf, and Filbert Jacques Melot. But he is also widely known by Chinese astronomers as his great work on the catalogue of novae. So
really?
But yes, he was one of these chaps, and I came across some of the literature that was is on the NASA site. Concerning the Great Debate and things like that. And his name crops up a real lot. He was one of the main instigators. And he, as I said, he was already of the mind that what they called nebula were in fact galaxies.
Galaxies in their own right, yeah.
And he did lots of work. And in fact, there's lots of people involved in this. I'm just holding up one paper. And when you start reading through it, it crops up a lot. And plus a lot of other famous names. Like I say, you've got Hubble and things like that. And it's the actual document I got at the moment. It says Dismantling Hubble's Legacy. Because we all remember that Hubble, or we all attribute Hubble as being the person who made the massive discovery. But it was standing on the shoulders of other people that he actually was able to do
absolutely.
that.
But that's always the way, isn't it?
Yeah. And as you read through this, they all use other people's workings and things like that. But they were very slow on accrediting the work that they were using.
It's like
make their decisions.
It's like Watson and Crick. If they hadn't had the X-ray crystallography of Rosalind Franklin, they could not have deduced that the DNA has a double helical structure. So and it's another lady who sadly is just not, or wasn't at the time. I think she's
recognized.
At the time, she wasn't recognized for the work that she did. And
she was a game old girl because she went in and she chinned him.
Oh, absolutely. Yeah.
When she found out, then he was taking glory for it all and all that without citing her.
Well, they literally broke into her office, as I understand it. I'm not saying this is absolutely true, but I've seen this in a couple of documentaries that the Watson and Crick literally broke into her lab and stole the X-ray crystallographs from her office. And
because she was away or something.
That's right. Yeah. That's right. I mean, I have to say, in fairness to both Watson and Crick, I can't swear that story is true, but it seems to crop up an awful lot, and I don't think it's ever been denied. So anyway, that's how science works. Unfortunately, it's just the luck of the draw. Some people get remembered, and others don't. And people get remembered for far less work far less important work than other people. So
yes, I mean, when you drill down to on all these discoveries, you come across these amazing people in the background, as you said, that have been forgotten.
They'll be forgotten.
And their work was just as important as the person.
Well, like Hooke and Newton, exactly the same thing.
Yeah,
History remembers Newton, but you know, I mean, I know about Hooke and you know about Hooke, but you know, the average person in the street doesn't, probably. Very sad, very sad.
So that was Knut Lundmark.
Thank you very much. Very interesting. Another one of these fascinating people we keep turning up in our voyage across the stormy seas of the astronomical alphabet. So another person to add to the list of people who should be remembered, but sadly are not.
Sadly are not.
Yeah, that's a bit depressing, really, when you think about it. So let's cheer us up with something completely different, because L is for Luna 1, Russian spacecraft. And now, I wonder if you know this, Daz. Luna 1 was the first spacecraft to do 3 things. And it's got the record for the first time this was ever done. I wonder whether you know what any of the 3 are.
Was it the first one to orbit the moon?
No.
Is that the one that missed?
Indeed, but it's not. It's not the first spacecraft to have missed, unfortunately. But it does hold 3 other records.
Didn't it take a photograph of the far side of the moon?
No, that was Luna 5. I think was the first one to do that. Now I'm going to have to tell you, aren't I?
Yeah.
It was the first spacecraft to leave the orbit of the Earth.
Oh, yeah, okay, that makes sense. Yeah.
It was the first spacecraft, the first spacecraft fired at the moon, and it was also the first spacecraft to go into a heliocentric orbit. In other words, orbiting the sun. Now, you might say, well, why, if it ended up orbiting the sun, what's all that about? Because they fired it at the moon. How come it ended up in orbit around the sun? And it's because it missed. They fired it at the moon in 1959, this was. So, 2 years after Sputnik, the Russians fired spacecraft, and it was quite a heavy thing. It weighed 361 kilograms. And they fired it at the moon. It was equipped with quite a large suite of scientific instruments for the day. And they hoped to land it on the moon and get lots of information from it. But they had a bit of a mishap. You see, the Russians in those days did not trust automation. They wanted everything done manually. So this included the firing of rocket engines. And although the first 3 stages operated fine, nominally, as they say, when it came time for Luna 1 to leave the rocket and fire its engines to put it on a trajectory for the moon, the firing of those engines was carried out manually by the Russians because they didn't trust automation. So they communicated to the rocket via radio, and unfortunately, although the rocket fired perfectly, the engines on Luna 1 fired perfectly, they forgot to stop them again. And by the time they realized, it was too late. And in actual fact, it had given Luna 1 an extra 175 meters per second of velocity. And it just basically shot past the moon, missing the moon by nearly 6,000 kilometers. So unfortunately, it's one of those sort of Igor, did you remember to turn that engine off? Oh, yeah, put the vodka down, Igor, you had enough. So it shot past the moon, missing it by 6,000 kilometers, and went into a heliocentric orbit around the sun. Now, the Russians, of course, this was a big PR disaster because this had been, bigged up before launch. Russia was going to be the first country to put something on the moon, and they had to do something to save face. So immediately it missed the moon and went into a solar or heliocentric orbit. They renamed it Artificial Planet 1, right? and that's how they refer to it. And then they thought, that's a bit of a mouthful, we better give it a proper name. So they then renamed it in Russian Mechta, which means dream, which is quite appropriate when you think somebody was asleep in shutting off that rocket engine. That's quite appropriate. So anyway, so that was the story of Luna 1. It left Earth on January the 6th, 1959. So, it was an early space probe. And, let's be fair to the Russians. They had a lot of success with their lunar craft after that.
Afterwards, yeah.
Yeah, they did. And, the Russian space achievements are often completely underestimated because they still hold a lot of endurance records in space and things like this. And although all Russian spacecraft look like they're made out of bits of old tractors and vacuum cleaners, which they probably were, and the odd tank turret thrown in as well. Tank turret, that's right. They became in the end quite reliable, very reliable, and the technology. It always looks like ancient technology, but it's got robust testing behind it. Of course, later in the space race, they didn't fare so well. What with various huge rockets they built that exploded, and they lost the race to the moon. And once Sergei Korolev, the father of Russian rocketry, modern Russian rocketry, the father of the Soviet space effort, once he died, then everything sort of went to pot, really.
Yeah,
and they lost their way a bit, and they're laughing now because they've been up until the SpaceX's Crew Dragon. They've been charging the Americans through the nose to ferry astronauts backwards and forwards to the space station. So they had the laugh last laugh. So there we are.
Something like $300 million or something they're charging per.
Well, they were charging. What were they charging? Something. I think it got up to $82 million per seat each way. So you
could have a single.
No, that's right. You couldn't buy just a single ticket. You had to buy a return ticket. And the comrades were laughing all the way to the bank.
Yeah.
And good luck to them, because America had retired the space shuttle in 2011, which, looking at it, was far too early, and not really having a plan for the next decade to replace the space shuttle with anything else American, and having to go cap in hand to the Russians and say, "Oh, Gov, can you give us a lift?" And exactly. And that's what happened. So the Russians did very well out of it. And of course, now we have Crew Dragon, the first launch from American soil. Was it last year? I think it must have been last year. I lose track of time these days.
Yeah, it was 2000.
Was it? Yeah, it was about. Yeah,
it was March, wasn't it? If I remember.
It was. I thought it was in the spring. Yeah, I think it was March last year. And now SpaceX is booked to. With the failure of the Boeing Starliner, they're going to be doing all of it by the look of it, because Boeing made such a massive mess of the Starliner. I think personally, you'd be very, very unlikely to see it fly at all the way that it's going. And even if they fix this problem with the stuck valves in the Starliner, like we were talking about, Daz. Who's to say that when they get it back to the launch pad and go to launch it, there won't be something else? Exactly. After the debacle with not having tested the flight software, because they went to NASA and said, "Do you mind if we don't do these tests on the flight software before we fly? Is that all right?" And NASA said, "Yeah, go on then." And as a result, the mission was a near disaster, because the computer clock on the Starliner thought it was much further along in the mission than it actually was. And there was nobody in it. It was an unmanned test flight that NASA had insisted on. And it didn't get into the correct orbit. And it turned out there were over 80 software errors, any one of which could have destroyed the mission. And if there had been astronauts, they would have been killed. And then they get back, a year and a half later, it's okay, we fixed everything. And they get to the launch pad and the countdown started, and they discover some of the propulsion valves are stuck. And now it's back at the factory, and they're trying to work out what to do about it. So anyway, I digress, but that's far away from Lunar 1.
Well, as you said, with the space shuttle fiasco, where they retired it before having a replacement. I mean, like I said, it's only since 2020 that they've had an astronaut taxi service with the SpaceX. But the Russians, because the Russians weren't that far off of actually possibly putting a man on the moon, but when they realized that they were going to lose, and then they sort of like gave up on it.
I
don't know if you've seen any of those old films of their training techniques and things like that. I mean, it's almost comical. It's like silent movies.
Absolutely.
And then I can remember that they've always used the same sort of like space rocket, the Sputniks, not the Sputniks, the Soyuz.
Yeah.
And I can remember they built a super Soyuz. And basically all they did is they strapped a load more engines on it, and they launched it. And it went about sort of like a couple hundred feet in the air, exploded, and the hole it made in the ground was the launch pad totally disappeared.
I'll have to have a look for that.
There was this massive hole left in the ground where the launch pad was. And they sort of like stood there with their mouths. It was we go back to the drawing board.
I'm sure you've seen it, Daz, but there's a great video. Well, there are a few of them actually on YouTube. 10 greatest space launch failures, and you think, how on earth? Because what was that big Russian rocket? Oh God, what was the name of it? The massive Russian rocket that exploded on the ground.
I think that was the one. It just sort of they fired the engines, and it just left the sort of like the tower, and it just exploded. It left them really.
This was another one, and I cannot.
Oh, okay.
I'm getting old. I can't remember the name of it.
No.
Basically, it was being fueled on the ground, and somebody decided to stand underneath it and light a cigarette, and. It's true, and the whole thing blew up, and I think about a dozen people were killed.
Did they find the cigarette?
Well, this is what I wonder. I wonder how they knew that somebody had done that, because they weren't alive to tell the tale. But apparently that's what happened. They found his Zippo lighter, embedded in a wall a mile away. Anyway, so that's Lunar 1.
Basically, what I would like to the L is for Little Ice Age. Or should I say Little Ice Age?
The Thames freezing over and all that.
Exactly. For those who don't know, the Little Ice Ages were when we had. They were just quite honest. They were quite recent. The last one was between 1645 to 1715. That was the Little Ice Age, and then there was a smaller one a bit later on. The first one is linked to what we call the Maunder minimum, which is also known as the prolonged sunspot minimum, because these ice ages have been linked with the lack of sunspots on the sun during its cycles.
Yes.
And it says here, the Maunder minimum was a period around 1645 to 1715, during which sunspots became exceedingly rare. During a 28-year period, 1672 to 1699, within the minimum, observations revealed that there were fewer than 50 sunspots. This contrasts to a typical 40 to 50,000 sunspots in modern times.
Wow.
And basically, as I said, it was an ice age, and it was, if you go back and look at the records with agriculture and things like that, it was a very hard time for people at the time. And as they said, because they started measuring sunspots back in the 1600s, but then there's, like I said, there's this massive drop, and so I mean, not everybody believes it actually exists, and it was associated with the sunspot reduction, but it does seem very strange.
It's a bit of a coincidence, isn't it?
Yeah, when in 1790 to 1830, there was a second dip in sunspot activity, and we had what they called the Dalton minimum. And it was
Oh.
during this time in 1814 that the last frost fair was held on the Thames.
Yeah, because they held complete fairs on the Thames, didn't they?
That's right. Yeah, they had
Yeah.
complete markets and things like that.
And I've actually seen old paintings of this, and they actually had, bonfires on the ice on the Thames.
Ice, yes,
the ice was
very,
that
very
thick.
thick. Yeah,
that even a bonfire didn't melt it.
I was
Amazing.
actually thinking about it. I think there was even an ice fair in Doctor Who that was held on the Thames. And but I digress there. We won't go into Doctor Who. So yeah, so
thank you for that.
Yeah, that's all right. That's all right. So it's in fact, actually, just reading this, it says temperatures. It says like the Maunder minimum and the Sporora minimum. The Dalton minimum coincided with a period of lower than average global temperatures. I haven't heard of the middle one.
No, I haven't either. That's interesting.
Yeah.
You live and learn.
During that period, there was a variation of temperature of about 1 degree C in Germany. So, it's surprising how much. A lot of these have also been linked, possibly with volcanic action. It says while the year without a summer, which was in 1816, occurred during the Dalton minimum, the prime reason for that year's cool temperatures was a highly explosive 1815 eruption of Mount Tambora in Indonesia.
Yeah, in Indonesia,
which was one of the largest eruptions in the past 2,000 years. One must also consider that the rise in volcanism may have been triggered by lower levels of solar output, as there is a weak but statistically significant link between decreased solar output and an increase in volcanism.
Wow.
So there you go.
You never know, you see, but it does seem coincidental that Britain had the little. I presume not just Britain, but the whole of Northern Europe probably.
Yes,
had the Maunder minimum, that period when called the Little Ice Age that is attributed to the Maunder minimum. And the interesting thing about the Maunder minimum is, of course, we don't know what caused it because the sun hasn't done anything like it since. And if it is part of a regular cycle, it's a damn long cycle, So very interesting stuff.
I mean, the Maunder. When you look at the graph, the Maunder, it really sticks out because it literally bottoms out.
Yeah.
Because there were so few things on there. And it says while the Dalton minimum is often compared with the Maunder minimum, its sunspot number was slightly higher and reported sunspots distributed in both solar hemispheres.
Right.
Unlike the Maunder minimum, the coronal streamers are visually confirmed by Ezira Ames and Joseph Joachim de Ferres eclipse drawings in 1806, and it indicates similarity in its magnetic field, not with that of the Maunder minimum, but with that of the modern solar scales. Now, there was something here that, let me just read this. Right, that the minimum was described by solar astronomers Edward Walter Maunder, 1851 to 1928, and his wife Annie Russell Maunder, 1868 to 1947.
Wow.
Who studied 1868 to 1947, who studied how sunspots' latitudes changed with time. 2 papers were published by Edward Maunder's name in 1890 and in 1894 and in 1894, and he was cited earlier papers written by Gustav Sporer. Oh, there's that chap again.
That's him again,
Because Annie Maunder had not received a university degree, restrictions at the time caused her contribution not to be publicly recognized. Now, that sounds familiar, doesn't it?
Oh, again. Yeah. Goodness me.
So,
God, it's so frustrating that these brilliant women are just trampled,
Yeah, and pushed into the background and never heard of again.
Exactly.
Yes, we hear it so many times now.
We do. In fact, the 2 things I think to come out of our voyage through the alphabet so far, since we've been doing this program, is all, as you said earlier, all the brilliant people that history has just forgotten, and how many brilliant women there have been who've done amazing science, who've just been, completely trampled underfoot by men claiming the glory and taking all the credit for discoveries, and women just not having the opportunities to advance in science the same way that men could. It's just outrageous.
But unfortunately, if you look through the history of women in astronomy, it's not always been the case. Before we had this period when women were sort of like suppressed and all they couldn't write papers. They could, if they did write, have any discoveries, that had to be done through the husband.
Yeah,
they weren't allowed to communicate with people.
That's right.
Note and things like that. But before that, there were women astronomers who were teaching astronomy.
Yes,
and things like that. And so, what actually changed? It seems strange. And it all seems to be during the so-called Enlightenment.
Yeah.
Which has also been called the Great Disenchantment.
Well, I think if you look at the UK, that came about sort of in Regency times. There seemed to be this marked shift in attitude that perhaps men felt threatened that they were losing ground to women or whatever it was, but there was a definite shift in attitudes. And in America, of course, even until the early 1970s, there were still some colleges and universities in the US where women were not allowed to study degrees.
Yes, exactly.
And I say it's not so long ago because it doesn't seem very long ago to me. I mean, I know it was 50 years ago, but 50 years ago, women could still not go to some colleges or university to study degrees in America, which and of course we've got the other question of it wasn't just women, it was people of color. It was anybody who was not white and male basically got a rough time. And to be honest, in the States, in some areas, it really hasn't changed that much as far as I'm concerned. So there you are. But yes,
hopefully are improving. Yes.
Yes.
So that was the Little Ice Age.
Yeah, the Little Ice Age.
Link to the sun and the link to the sun. Yeah.
So London must have been a wonderland. I mean, obviously not a nice place to live if you didn't have money. Yeah. I wonder how many people froze to death in that period.
Well, yes. I mean, because I know, going back through the history books and all that, in these periods in the countryside, people, as you said, were starving to death because there was no crops. Because
that's right.
The one which what was it said? The year without a summer.
Yeah, exactly. The year without summer.
They couldn't grow crops, and also what crops were available, root vegetables, they couldn't get out of the ground.
No,
because the ground was as hard as iron.
I wonder if there are any figures about how many. I'm not being morbid, but I'm just curious as to how many people perished in the Little Ice Age.
I should think you should be able to go back and
I'm just thinking of London,
Yeah.
Because I have this image of London as it was. Mind you, a lot of that's been conditioned by Hollywood, I think, and other films, and especially Victorian London, where when I think of Victorian London, I think of groups of people walking down the street singing songs and dancing. And singing songs by Lionel Bart,
say Mary Poppins and all.
Mary Poppins and Oliver, and seeing the Artful Dodger standing on a street corner. God blimey, go! You're a regular caution and no mistake. And all of that. That's my vision of London, which is of course completely fictitious because it was a hellhole if you didn't have money. So
exactly.
So there we are.
Because it wasn't just London that had the frost fairs.
No,
all over the country. Yeah,
I'm sure. But I think we think of London because there were so many engravings and drawings and paintings done of London in particular that we think of London. But it'd be interesting to see if there's any artwork of other cities during the Little Ice Age.
I've seen etchings of the ice fairs held at Shrewsbury.
Oh, Shrewsbury, really?
On the.
I'd like to see those. I love art from that period.
So I have seen etchings of those. So I suppose if you go online and Google images of ice fairs, you'll probably be able to find them.
There we are then.
Yeah.
So there we are. So is the clock catching up with us, Daz? I think it probably is by now.
Yes, it's yeah. I should think. Yeah, that's it. Yeah, that's it.
Yeah. Okay.
Yeah.
Well, listen. Thank you so much for listening, listeners. We hope you found it interesting, entertaining, educational, maybe. And we are back next week when we move into the murky world of the letter M, if my alphabet is correct. So Daz and I will go away and come back with some things to tell you about in the universe beginning with the letter M next week. Thank you so much for listening. And it's a goodbye from Daz.
Yes, thank you very much. Stay safe, everybody. And I'm looking forward to M for Mother.
M for Mother. And so I think we both ought to agree now that we're not going to have Moon.
Yeah, that'll be cheating. We could go.
Yeah, that'll be a little bit too easy. That's
we could do a week on
Moon. We could do weeks and weeks on the Moon,
especially with those chaps in Hawaii.
Yeah, that's right. That's right. So we'll proscribe the Moon for our investigations, and we'll be back next week with the letter M. Until then, have a fantastic week. Look after yourself. Stay safe, and I'll leave the final word to Daz.
Well, thank you very much, and we will see you all next week with the letter M, the spiky one.
The spiky one. Da, da, da. Bye, everybody.